Hello students, let us discuss about the analog output model. So last class I have explained you about the various analog input model. You know very well analog input model is nothing but which converts analog signal into equivalent digital signal or digital values. If we give a voltage, then it will be converted into number, but in analog output model the number will be converted into voltage. So that is the difference between analog input model and analog output model. Generally, how do you control the induction motor speed? So it is a schematic or a schematic diagram of a speed control of induction motor using variable frequency drive. So this is known as VFD or a VSD, variable speed drive or variable frequency drive. So this red color and black color is a control terminal. So by applying variable voltage at the control terminal, you can control the speed of your induction machine. The input is single phase AC, the output is 240 volt 3 phase AC, and the output of the VFD is connected or is given to your 3 phase induction motor. So here this point is known as drive speed set point terminal. This terminal plus and minus is represented as control terminal or drive speed set point terminal, and assume the no load speed is approximately equal to 1500 rpm. It is approximately equal, but the actual speed of an induction motor is less than 1500 rpm if it is a 4-pole 50 Hz machine. And across this terminal plus and minus, you have to apply the variable DC voltage, not AC. You have to apply variable DC voltage of 0 to 10 volts. Suppose if I apply 0 volt across this drive speed set point terminal or control terminal, the motor speed will become 0. If I apply 1 volt, so 0 volt 0 rpm. If I apply 1 volt, then the motor will rotate at 150 rpm. If I apply 2 volt, then the machine speed will be 300 rpm. If I apply 3 volt, then the speed will be 450 rpm. For 5 volt, the speed will be 750 rpm. If I apply 10 volt, then the speed of the machine is 1500 rpm. The machine is running at no load speed, that is 1500 rpm. So by controlling the terminal voltage or drive speed set point voltage or control voltage, you can control the speed of your induction motor. So that is the concept behind VFD, variable frequency drive speed control. So who will give this 0 to 10 volt? So if you want to control your speed, control the speed of your machine, then you have to control this control voltage, that is terminal voltage. So who will give this 0 to 10 volts? Your PLC or your controller digital outputs model will give this. Digital output model means your D2A converter will give this 0 to 10 volts. So this is a representation, schematic representation of speed control of induction motor using PLC or a controller. So we will discuss it in our future lecture. Thank you.